for you. Now we're going to start to talk about some other ways to look at it, some word problems where you have to notice a pattern and set up equations for it. Here we have a number of months laid out as our x. Our total amount, y is usually always some sort of total, and here we have 150, 200, and so on. And they want to know, according to the information, which of the following is true. Now I want to point out you can't do the linear quadratic thing here because notice we're counting by 2 here, then it jumps by 6, then it jumps by 12. Here it jumps by 50, it jumps by 150, it jumps by 300. This is not consistent. So we can't do the linear quadratic. You might be able to notice the pattern and fill in the gaps, and then you can decide stuff like that, but in this case you can't. Now the important thing here is to determine what changes or what varies. And in this case the thing that changes is the number of months. Okay? And then what is the one thing or the starting point that wouldn't change? If you're getting an apartment, you're going to pay consistently each month. And so it's going to change how much you've spent based on how many months you've lived there. But the one thing that'll never change is your registration fee. Notice they say it's a one-time registration fee. So that's going to be our y-intercept. The changing thing is going to be connected to the months or the x, and that's going to be our slope. So here, if you look at it, so the equation I'm going to give you here is y equals 25x plus 50. And you'll notice that the monthly fee in the long run is going to wind up being 25 bucks per month. It's the slope is connected to x, which is the number of months you've been there. So this is the thing that changes because it has the variable. It's varying. The thing that won't change is the one-time thing. There's no letter connected to it, and that's the registration fee. So if we're looking at this, then they say, is the monthly fee $50? No, we said the monthly fee was 25. Is it $37.50? No, it looks like A and B are both out. Then the registration fee is at 75. No, it was a one-time 50, so D must be the answer. So once you've got your information, you can determine what changes, what doesn't change. That's going to help you set it up. And then finding just in general the slope and the y-intercept from that information. You'll be able to help. So I guess the idea is if you set up your equation, you'll understand what these numbers mean based on what changes and what doesn't change. Let's look at a few problems that use this. So Harris has $20.92 to spend on video game rentals at a local video store. The store charges $3.95 per video game rental plus $3.50 just for a membership. What is the maximum number of games Harris can purchase? So the first thing to identify, and I'm going to tell you, it's easier to identify if you look for keywords like per, for each, every, or for every. Because what's going to happen here is you'll see $3.95 per video. That's going to tell me I'm multiplying $3.95 times, that's what I see that per as, the number of video games that I'm getting. Plus, that tells me there's a plus sign in the equation, $3.50 for membership. Well, I can tell that that's a one-time thing. That's when I initially get there, I'll pay $3.50. After that, I'm paying $3.95 times however many number of games I have. So that's the variable there. So when I set this up, y is again the total. In this case, it's the total dollar amount. $3.95 times the number of games plus whatever that membership is. So x represents the number of games. When I plug into this, and that's the other piece, because we're trying to predict or conclude things, once we've got our equation explaining the pattern, we can then say 2092 is what the total we have to spend, so we plug it in for y, everything else stays the same, and then we just solve for x to figure out how many games we can get. X comes out here to 4.4. So when they say what's the max number of games, can you get 3, 4, 5, or 6? A lot of people rush to round this up to 5. But if you can only afford 4.4, there's no way you can afford 5. So here B is the answer. The most we can get is 4, and it looks like we might have just a little bit of money left over. Okay, here's another one. Tyler wants to buy a video game system for $375. He can pay for the system in 12 months. If he pays $75 now and $25 each month, so there's the keyword each. How will the number of payments be affected if Tyler pays $75 now and $30 each month? So there's another each. So here we have two scenarios. We're setting up two equations. And we know that the starting point, or the one-time thing, is that $75. Then after that, the monthly payment is either $25 in scenario 1 or $30 in scenario 2. And I know those are the slopes because those are They have the word each next to them, which tells me I'm multiplying those times the month. So it might be M or X that we call that. In this case, we call it X. So for the first situation, we have Y, the total, equals 25X, the number of months, plus that $75 that he's paying. Then we plug in, and we know 375 is what he owes, so that's going to be in the total. We're going to solve for X, just moving the only numbers and then dividing. We're going to find X equals 12. So that was the number of months. Here it's 12 months. But then if we change this, and we say, remember, X is the months, we're going to now plug in 30 for the slope. That's how quickly things are changing because of that for each that we saw in there. It tells us to multiply the two. We can plug 375 back in and see how many months it would take to pay if he made that payment plan. Here the number of months is 10. What's the difference between them? Looks like here he can pay it off 2 months faster. So he will make 2 fewer monthly payments, it looks like. So G is the answer for this one. Here's our final slide. Now the idea is, in the long run, if you are given answers, you're given this table. Remember, these are inputs, this is what you should get out. So really all you should have to do is test the data. So this first one, 2r plus 52, if you plug in 1, 2, 3, and 4, here's what you're going to get out. 2 times 1 is 2 plus 52. That'll give us 2 times 2, which is 4, plus 52 is 56. And you're just going to continue to plug these numbers in. So whatever inputs they give you, use those, and then see what you get for outputs. And then check to see if they match. Now the first one does, which is why you don't want to stop after 1. You want to plug in several of these, at least 3, if not all of them. Here we plugged in all 4. But notice that our second one, 58, doesn't match 56, 62 doesn't match 58, and 66 doesn't match 60. So we got to move on to B. For B, it's going to be R plus 54, so if we plug in the inputs they give us, that'll be 1 plus 54 is 55, 2 plus 54 is 56, and so on. Again, that doesn't match the outputs they gave us, so we move on to the third one, 4R plus 50. Plugging it in, 4 times 1 is 4, plus 50 is 54. 2 times 4 is 8, plus 50 is 58. 3 times this is 12, plus 50 is 62, and we finally get 66. Notice those outputs match. And so we didn't stop at just the first one here because we would have got it wrong. We plugged in all of them, which told us C is going to be the answer in the long run. So you've got this system set up for you on how to clearly organize your data, how to visibly see what's happening, notice that pattern. It's real critical that you do that. And then how to come up with the equations to describe those algebraically, and then how to form conclusions. And really in the end, even if you just want to do this to check and see if you got it right, always test your data.